Okay, so in this video, I'm going to talk about permutations and combinations. So here what we have that I've written out here is a set of 5 elements. Now, a permutation of that is essentially a reordering of those elements. So this permutation here, the second one, was obtained by changing the order of the first 2. Now, it just so happens that counting the number of permutations of something is actually something that's useful in the real world. So for that reason, we're going to take some thought equity and invest in trying to understand it. So what we have here is a situation where the first position of the ordering, you could say, has 5 options. Now, I'm not going to tell you which option it is, it just has 5. It can be any one of these 5 options. Okay, so the second position has 4 options because it can be any one of those except for the one that was picked to be first. Now, again, we haven't identified those, so that doesn't matter. The third position, much like the fourth position, can be any of those remaining elements that haven't been picked for position 1 and 2, and the pattern continues. And this pattern here of multiplication of 5 times 4 times 3 times 2 times 1 is a pattern which has a representation in mathematics that's rather concise. We call that pattern, so let's say we had a set of size n containing distinct elements. Now, for those of you that know a bit of set theory, all sets have only distinct elements, but for those that aren't as familiar, I decided to include that comment. So if we had a set of size n, then there are n factorial possible permutations. Okay, fantastic. So now if they ask you something like, how many ways are there to reorder a deck of cards? 52 factorial. That's a really goddamn big number, because that's 52 times 51 times 50 times 49 times 48, yada yada yada, times 2 times 1. So that's huge. So factorial is something that grows actually quite quickly. Okay, so now we're going to go to something that's related, but also somewhat important. So in this case, suppose we had a box of n elements. In this case, you could think of it as people attending a party. So there are 7 people in this party. And suppose we draw from that box k elements, so k people, and we want to calculate the number of permutations. Now, in this case, order matters, because we're going to be calculating the number of permutations. So it's important to understand that the fact that order matters changes things. When order doesn't matter, we're going to see something later when we develop the idea of combinations. But right now, order still matters. So using the same kind of logic that we used here, the 5 times 4 times 3 times 2 times 1, we look at the number of possibilities we have for the first position. Well, there are 7, because there's 7 attendees at this party. Now that we've picked one, as let's say this was a raffle, and there's prizes. So we picked the first prize went to some guy, doesn't matter, or girl. Now the second prize can go to one of the 6 remaining people. and so on and so forth. So what we can do is actually generalize that concept and write it down. And the way that we do that is we notice that what's happening here is that we have n times n minus 1 times n minus 2 times n minus 3, or we can notice this is n minus k plus 1. So if we notice that it's n minus k plus 1, we can actually write it out as this. So 7 factorial over 7 minus 4 factorial. Because if we write it out this way and we cancel, we just wind up getting 7 times 6 times 5 times 4, which is what we had here. Okay, so this generalizes to when drawing k elements from n elements, there are n factorial divided by n minus k factorial permutations, and we sometimes denote that as p n k. So in this case, p n k is equal to n factorial divided by n minus k factorial. And where this comes from is just this observation that the first one can be n, the second one can be n minus 1, the third can be n minus 2, and the fourth can be n minus k plus 1. Okay, perfect. So now we need to look at another question that's actually important: combinations. In this case, we don't care about the ordering, and instead we want the number of possible k-sized subsets. Number of possible k-sized subsets of n, where here order really doesn't matter at all. So for example, 100 people in a conference, how many different groups of 5 people can be made? In this case, it doesn't matter because there's no prizes being made. It's just you're forming a group. It could be a prize raffle as well, but the group would all win the same prize, so it wouldn't matter who was picked first. So what we're going to do is leverage the fact that we've done the harder problem, which is to solve not only how many different groups, but also how many different groups and how many ways can they be ordered. Now ordering doesn't matter. So the way that we take out ordering from this more complicated problem that we've figured out and develop the idea of a combination, we'd have the combination nk, and that's just going to be n factorial divided by n minus k factorial. And now we have to take out the number of permutations in that small group of k elements that we've selected, because remember, we don't care about the order of that group. If it was a raffle, they all get the same prize, so there's no difference between that. And so how many permutations are there of that group? Well, we figured that one out. Okay, so in this case, it would be k factorial possible permutations in the group of size k. So we'd have to multiply by 1 over k factorial. So this can be interpreted as the number of possible ways to choose a subset of sized k from a set of size n. And this has a notation in mathematics: n choose k. Okay, And so in further videos, I'm going to be giving some examples with this, but I thought I would just introduce the concepts so that you could familiarize with that, you could understand where these formulas come from, and if you have any questions about what I've done here, let me know. So this n choose k is just n divided by n minus k factorial divided by k factorial, which again, to remind you, this part here is the permutations of that k group, and this part here, or the permutations, it's the number of different orderings of the k group, including permutations that you can choose. And this part here is just the number of permutations of the k group that we're removing from the number of ways, because it doesn't matter what order you are in once you're in k, so in the k group.